We turn now to the topic of integration by parts. This is the first of our advanced integration techniques. So in order to set the stage for what integration by parts is, what I want you to do is recall the product rule from the unit on derivatives that you took in Calc 1. So recall that if I have two functions, f and g. If I take the product of f and g and want to find their derivative, actually let's use Leibniz notation for this. If I take the product of f and g and want to find their derivative with respect to x, this is going to be f times the derivative of g plus g times the derivative of f with respect to x. So that's the product rule. I know that you've probably seen this in other forms, but that's whatever form you remember it in, that is what the product rule is. So we're going to use that here. The traditional way to teach this is to refer to two functions u and v. So we have two functions u and v of x. We're going to start with their product uv, and now we're going to take their derivative with respect to x. So the derivative of uv with respect to x is u times dv over dx plus v times du over dx. So that's just the straight derivative product rule. Now what we're going to do is we're going to multiply that entire equation by dx, because you see we have dx in the denominator, everywhere in the equation. So this becomes d uv equals u dv plus v du. Straight multiplication right there. Now what we're going to do is we're going to integrate both sides. So what I'm going to do is I'm simply going to put an integral sign in front of both sides of the equation, and we'll see what we can do with this. Well, first let's do the left side. That's going to be fairly easy, because if I have, let's say, the integral of dx, we know that that's just going to be x. Technically it's x plus c, but we're just going to ignore the plus c for a minute. We can always put it in later if we need it. So the integral of dx is just x. I'll leave that up there for reference. And for the same reason, the integral of d of the quantity uv is just going to be uv. So this will be uv. And then all we can really do with the right side is we can just observe that integrals are linear. You know that the integral of f plus g dx is equal to the integral of f dx plus the integral of g dx. So I can split up the right side that way, but that's really all I can do with it. So this becomes the integral of u dv plus the integral of v du. I can now rearrange this a bit. I can rearrange what's on this equation. I'm going to subtract integral of v du from both sides, giving us uv minus the integral of v du is equal to the integral of u dv. And finally, I'm just going to write it in its traditional form by switching the sides of the equal sign, and this becomes the integral of u. There we go. The integral of u dv is equal to uv minus the integral of v du. Let's just be very clear about whether we're talking about u or v. And this equation is what we call the integration by parts formula. And that's what that is. So what we're going to do is use the formula, and it becomes a little more clear what we're doing once we actually start to do some examples.